Good afternoon. My name is Tzone Tien. Um, I am currently work in Maryland Department of Environment as a Deputy Program Manager in the wastewater permit program. We review and process in the permit application for wastewater discharge, and I specialize in the groundwater discharge permit. Today my presentation divided into 5 sections. Introduction, kind of to introduce to you the status, the global water resource, and also the second section talking about climate change and water resource availability. Section 3, water reuse, and 4 and 5 is to do with Maryland Department of the Environment. Number 4 section is introduce the guideline. Number 5 is give you 2 case studies. Let's see this slide. The water resource in the earth, 97% in the ocean, only 3% is fresh water, and those 77% of them is in the ice cap or glacier. You won't be able to use it. 22% in groundwater, 1% on the surface portion of it. And out of this 1% of surface portion, 61 in the lake, 39% is in the air or soil. The river only accounts for 0.4%, so we can see the resources are quite limited. This is the diagram of the United States in 1901 to 2014. You can see the temperature increase in this area of the U.S. in the western portion, kind of pinkish to red color, increase 1 to 3 Fahrenheit. 3 Fahrenheit is equivalent to about 1.7 centigrade, and the northeast portion of the United States also had a higher temperature increase too. The place without temperature increase is in the south area nearby Louisiana, Arizona, which is a gray color area. That area, the temperature is hardly change or even a little bit less. Now this is a record between 1901 to 2014. Now the global warming effect do affect our daily living in the earth. You increase the sea level, it will affect our water supply, and other will increase the flooding and also create a drought situation. That's what created water quality impairment. And since this will affect our water resource, not only just quantity, quality, that's also will affect our daily activities such as energy production, infrastructure, construction, human health, and also agricultural ecosystem. This diagram is a water cycle consider the warming effect and how that affect the U.S. both in the West Coast and also in the East Coast. In the West Coast, it will get hotter, but it will get drier. And you can see the diagram here that the snowfall in the West Coast will be reduced, and then probably on the East Coast will get wetter, get more rain, which will create runoff and will create flooding situation. Now this picture taken in a lake, Folsom Lake, northeast of Sacramento, California, 25 miles. Back to 2011, it's a normal rainfall year. They got plenty of water. But when 2013 and 14 is a drought year, and you can see the whole reservoir is dry, not much water in there. So this is the drought situation affect our water supply. Now back to Baltimore County. This is nearby me, a reservoir called Pretty Boy Reservoir. Back to 2001, 2002, we have a dry year, and then see the reservoir don't have much water. On the right side, back to 2000, 1 year later, 2003, we have a 62.7 inch rainfall in 1 year. That's much greater than 34 inch in 2002. So we got plenty of water, so the reservoir is filled with water and the snow in the wintertime. Now this kind of tell you that the drought situation create not much water resource we can use, as shown in the picture in the lake. However, if we can reuse it, the diagram below showing there's a wastewater treatment plant. They can supply reclaimed water, supply to the factory, supply to the farm, supplies to recharge groundwater, and that can be pumping out, reused by the city for other activity. I took this picture during the drought year. You can see the corn pretty dry, probably die. And then a couple of years later, we put a irrigation system in the same farm, and they can irrigate with the treated wastewater, and you can see how green the corn is. So this is a big difference with water reuse, make the crop grow better. The definition of water reuse is, according to our guideline in 2019, is the use of reclaimed water, which is treated wastewater, for direct beneficial use or indirect potable reuse, such as groundwater recharge or any reuse under control situation defined by in this guideline. Now this slide shows you the water reuse rate in top 4 states in the USA. Florida #1, Arizona #4, range from 220 million gallon per day for Arizona to 584 million gallon per day in Florida. 1 million gallon per day is equivalent to 3,700 cubic meter per day. So you can convert this into metric system. This is the water reuse rate in Maryland in 2018. We had total usage of 10 million gallon per day. That water reuse rate compared with California, 528 million gallon per day. We only roughly about 2% of California water reuse rate. Most of these water reuse are using for spray irrigation, account for 54%, and some are using for power plant, 25%, and then some are using for infiltration, recharge groundwater, 10%, and so on. So this is the breakdown of our water reuse in Maryland. The history of the Class 4 guideline is back to 2009, September. We organized a water reuse committee, which has 25 members from consultant firm, from county agency, from the plumbing board, and we meet once every 2 or 3 months, and we prepare the guideline. We use in the guideline from other states, Arizona, California, Virginia, as a reference, and we prepare our own guideline. The guideline was draft, final in 2015, and posted in Maryland MD Department of Environment website for review. And in 2019, we finalized, and this guideline can be downloaded from MD website. The guidelines are currently used to review the project, approve the project for water reuse using reclaimed water, Class 4 reclaimed water in Maryland. In the future, we will incorporate this guideline into a Maryland regulation. The summary of the guideline can be included in here. This guideline defined the water quality of Class 4. Maryland reclaimed water had 4 classes, 1, 2, 3, 4. 1 and 3 is using for spray irrigation in the farm or golf course. That's governed by another guideline called MDE guideline for land application reuse of treated wastewater. The guideline have 14 chapters, and the title of each chapter is in here. It's including the design criteria in Chapter 7. It's including the monitoring requirement in Chapter 5. It's including the reporting requirement in Chapter 13. The purpose of this guideline is we want to provide an additional resource, reclaimed water, to promote water reuse, and to apply this Class 4 guideline only for treated wastewater come out from treatment plant. So this is the general purpose and the scope, and this guideline don't cover the gray water and rainwater reuse. Now this is a comparison. As I told you before, we have 4 classes of reclaimed water. Class 1 are typically using lagoon as a treatment. Class 2 typically using like active sludge or other advanced treatment. Class 3 and Class 4 are more advanced. It could be like a membrane treatment. You can compare the BOD. Certainly, the Class 1 is the lowest quality, and then Class 4 is the highest quality. And then we use NTU for Class 3 and 4, and using solid for 1 and 2. And another thing we have to point out is that we require choline residue for Class 4. At the point of use, at the wastewater treatment plant, come out, you have to have a choline residue to protect the public health. This is a comparison between our Maryland Class 4 water quality to other 8 states in the country. We are pretty much similar. If you see the NTU, the turbidity requirement, we are very similar to Washington State, very similar to California, very similar to Arizona. Our BOD are different. Standalone, we use 10 ppm as a limit. However, we do have a choline residual requirement. Other states don't have it. So you can compare the difference between our guideline to other state guideline on water quality. The water reuse type for Class 4 in Maryland, you can use it for fountain, use for car washing, use for concrete mixing, all this usage. I highlight red for crop irrigation. That means we can irrigate Class 4 for any food crop that can be consumed by human directly, such as vegetable and fruit. But if you want to use Class 4 to irrigate the food crop, you have to have advanced treatment to meet, including the filtration and chlorination, disinfection to meet the Class 4 water quality before you can irrigate to the food crop. Also outlined here is the toilet and urine flushing, allow you to flush the toilet and not in a single home, in the community apartment complex or commercial building. You have a certified plumber to take care of the system. We don't want to in a single home using the toilet flushing because the children, young children can go to the toilet and contact the toilet water. We don't want to. We want to avoid a public health risk. Highlight of the guideline included in here. I can use some of the example. So I mean, if this reclaimed water Class 4 is come out wastewater treatment plant. If the wastewater treatment plant want to use that reclaimed water to irrigate their, to wash their equipment or for their operation, you really don't have to follow our guideline. Now that's exception. And a permit, item number 3, a permit from MDE, Department of Environment, is required. Okay, and as I mentioned before, the fire protection and the toilet flushing only can be used for commercial building. For single home, we are not going to take the risk, public health risk in a single home situation. So this kind of the highlight, and other highlight including when you monitor turbidity, number 7, you have to use the online turbidity meter monitoring requirement. And number 6, power plant water reuse, Department of Environment is not approval agency. You have to approve a Maryland Public Service Commission. They are the one regulate the power plant in Maryland. So next, I want to introduce you. We have 2 case studies. One is Little Patuxent wastewater treatment plant. That treatment plant produce high quality water. Capacity of the treatment plant about 30 million gallons per day, and portion of it using as reclaimed water for the federal building in Fort Meade. And second case study is an environmental research center called Smithsonian. This is in Maryland. That's another case study of water reuse. So for Little Patuxent, this wastewater treatment plant going to the end user for me. This project, the water reuse volume using 5 million gallons per day, we permit them roughly about 19,000 cubic meter per day from this Little Patuxent treatment plant going to cooling the building in Fort Meade federal facility, also cooling the equipment and computer. 2014 we approved this for water reuse, and then the requirement of this permit saying that their required reclaimed water had to meet free chlorine residual requirement, provide adequate level, and also the NTU, the turbidity, has to be less than 5 NTU. This is a schematic diagram. Little Patuxent wastewater treatment plant, their wastewater discharge to stream, portion of it going to outflow lamp 102, going to federal building, using, and then after that discharge to Fort Meade wastewater treatment plant, and then eventually treated by this treatment plant going down to the stream. In outflow 102, we require they monitor the total residual chlorine, turbidity, flow, solid, nitrogen, and phosphorus. This is a diagram showing that the reclaimed water pumping station pump the reclaimed water to cool the building in Fort Meade. The blue color building is already there. The color yellow, color red building, they are phase 1 and phase 2. That will be constructed in the future. It hasn't built yet. This is a picture taken in when I visited them in 2017. This is a pumping station for reclaimed water. Its construction complete in September 1st, 2015, 5 years ago. Inside the pumping station building, there are 5 reclaimed water pumps. Their capacity is 5.5 million gallons per day. And their flow in the initial period of time, the flow, because the building is so constructed, so you're using a small amount of reclaimed water until the ultimate flow about 5 million gallons per day. This is a reclaimed water pipe inside the pumping station. See, this color has to be sort of like a pinkish purple to differentiate from the potable water, which is a black pipe right here. So this pipe has to be color in purple. This is a backflow preventer. See the yellow pipe connect to the flow preventer. This copper yellow color, and then prevent the backflow into the water supply pipe. See this governor, this civil pipe is a water supply pipe. We don't want them to have a close connection, so we need this backflow prevention device. This inside the pumping station, they have a chlorine tank, a chlorine dosage panel, and also inside the pumping station, they have the online turbidity and chlorine meter to measure the residual chlorine in this particular date, September 12, 2017. I took the picture. Their chlorine residual is 8.3. However, their turbidity is 0.7. That's meet our requirement. This is the water quality from this treatment plant for going to the Fort Meade on the 2018 January to December. The range of chlorine residual and the range of flow. The average of chlorine residual is 2.2. The flow they use is 0.79 million gallons per day, which is equivalent to roughly about 3,000 cubic meters per day of reclaimed water. Now this is a Smithsonian Research Center. They also had a reclaimed water reuse project. Smithsonian Environmental Research Center is located not far away from Annapolis. Annapolis is the capital of state of Maryland. So this agency is not far away from the Annapolis. They use treated wastewater for the toilet flushing, for fire protection, for outdoor irrigation. We permit this facility for reclaimed water reuse in August 25, 2016. Create outflow number 2 for water reuse. Outflow number 1 is for there to discharge their treated wastewater into a drain field. If they are not using the reclaimed water, all their treated wastewater go into the drain field. The water quality is shown in the next slide. Requirement in the discharge permit saying they have to meet this kind of water quality before they can be reused. BOD 10, turbidity less maximum less than 5 NTU, and so on. Pathogen and also total residual chlorine have to meet 1.5 to 4. Here is a schematic diagram. On the left side, there's a treatment plant. They treated, push and go into a manhole. The manhole had a control valve they can divert to the drain field, or they can divert to reclaimed water portion of it. And those reclaimed water system, including has a filter in the building, and also UV and chlorination. After they treat it, then they can pump to the water tower, store there. This water tower will have 300 gallon capacity can store before they can be used for fire protection of storage. This is the treatment plant, sequential batch reactor treatment plant. They are underground, they bury underground. After treated by SBR, they go to this micro filter and then go into this UV unit or chlorination. They can choose either using UV or chlorination. Actually, I think they have to use chlorination to maintain a chlorine residue. So this is the water tower, the picture of it, 300,000 gallon, roughly about 1,136 cubic meter storage capacity. And here is the reclaimed water to recharge the stormwater pond to support the vegetation growth, or they can irrigate on their campus lawn. Besides that, they're also using flush toilet. So this is my presentation. Thank you very much, and have a good day.